Hello, everyone. I am Matt Topol. I am a member of the Apache Arrow PMC, committer on Iceberg, created Iceberg Go, wrote the book on Apache Arrow, and so on. I'm also the co-founder of a lovely new startup, Columnar. We did our whole press release announcement stuff with our seed funding a couple weeks ago. Come look at us, but I will come back to what we do in a bit. The point of this talk here, I'm going to talk a bit about, how many people are actually know or familiar with Apache Arrow at all. Cool. Okay, so I want to circle back on more detail to Apache Arrow for the couple who didn't raise their hand. But first I want to kind of touch on, every so often, every year, there is a lovely gathering of database folks called VLDB. And back in 2017, there was a very important and forward-looking paper that was submitted and was presented at VLDB, which was this lovely paper by Raasveldt and Hannes Mühleisen, lovely folks from Amsterdam, who you might recognize as the creators of DuckDB, which they went on to do after this. Now, the important part here is that way back in 2017, they recognized a problem in how databases were basically holding all of your data hostage. And it's gotten a little bit better since then, but not completely, because the issue is the client protocol you use to talk to that database and get your data out. Now, the paper was concerned with specifically the problem of query result retrieval. Okay, now they did a whole bunch of comparisons using the database client server protocol, did benchmarks comparing the protocol that's included in the database and some other potential ideas, and examined a lot of the design decisions that came into these protocols that were used, and also created a novel idea for a database protocol to solve the problems that they were observing. And so the central observation was that query result retrieval turns out to actually be a very expensive operation. And most people are concerned with either the operations in the database, or how the database is doing the I/O to get the data, or what the application does with the data. And people almost never actually look at the protocol that's being used to actually retrieve your results. And largely, the cost of this expense of query result retrieval is the overhead of serialization and deserialization of that data, because the format in memory of the data in the database is not necessarily the format of the data that the application wants. And so there's a high cost to the serializing it on one side and then deserializing it on the other side. And so all but one protocol they examined transmitted the data in a row-oriented format. And there's a couple different ways that row-oriented serialization is just a bad fit and causes inefficiencies. For one point is that a row-oriented system does not compress as well as column-oriented data. Data of the same type, contiguous chunk, will compress better than row-oriented data, which is various things of different types all collected there. And that's a source of different efficiency. Now, the other big thing that was happening, especially at that time, was the advent and usage of the fact that increasingly the source system is column-oriented in memory to do analytics. And increasingly, the destination system is also column-oriented, like pandas or polars, or because you wanted a data frame, you're doing visualization, stuff like that. Which means that you were having this enormous serialization and deserialization overhead of going from a columnar system, converting it all into rows for the protocol, and then converting it back into columns at the destination. And so they chose for this paper, for their novel protocol, they obviously chose a column-oriented format. And then they compared different kinds of compression and compared it with bandwidth. Now, the conventional wisdom, especially at the time, was you want the best compression you can get. Heavyweight compression, make it as small as possible. The problem is that that's only actually beneficial under extremely small bandwidth constraints. In fact, if you're doing it locally, your best option was no compression whatsoever. If you take a theoretical maximum bandwidth, your best option is no compression at all. For most bandwidth cases, even though the final result is not as small, the cost of that compression and decompression was more than what you saved by sending fewer bytes, which meant that the only time you really wanted to use the heavyweight compression was under the constraints of very heavy bandwidth. And so their novel protocol made compression optional. And then they ran the benchmarks with and without the various types. So it was always either a lightweight compression, and the compression was optional so that if you didn't need it, you didn't have to use it. And so they ran their benchmarks and all these setups, and this novel column-oriented protocol against all of the types they compared with using a local LAN device, a loopback LAN, a gigabit, and then 100 megabit. And you can see that their novel column-oriented protocol across all of the options, across all the benchmarks, ended up being significantly more performant because it was column-oriented, because it used a lightweight compression or no compression as optional, and so on. You know, their novel protocol was better than any of the built-in client protocols, and all that compression just slowed things down on arbitrarily fast connections. So they wrap up this paper by emphasizing that these row-based protocols that were designed in a completely different era are increasingly not useful, and they're actually very unsuitable for modern data handling and modern data analytic needs. Thus, Apache Arrow, because in 2016 is when Apache Arrow first came out, and Arrow was brand new. We don't actually know whether or not Hannes and Mark actually knew about Arrow yet when they wrote the paper. We don't know. But even if they did, it was, at the time, unclear whether or not Arrow actually provided the solutions they were asking about. You know, Arrow is still very, very new, but for all intents and purposes, the protocol they described was basically Arrow with some minor differences. Column-oriented, optional compression, batch columnar serialization, query results, and even allowing completely uncompressed and no serialized overhead. You know, so at the time that they wrote the paper, Arrow was still new and wasn't, you know, what it is now. But now we know it's just basically that's what it is, and you can see it in the development of DuckDB and the adoption of Arrow by many other systems. And so over time, in the earliest days, Arrow was not widely used as an actual data transfer for networks. It was mostly used for data communication within a process, for shared memory, and so on. And then later on, the Arrow community, we put together an actual RPC protocol, client-server protocol, using gRPC that we called Flight, and was built around using Arrow as that network protocol. And then, of course, that then evolves into Flight SQL for doing more of a database-oriented connection protocol framework, which then leads to ADBC as an abstraction over database connections. If you've ever dealt with the horrors that are ODBC and JDBC, the point there is ODBC and JDBC are row-oriented APIs inherently, and almost everything goes around, and then, you know, their internal network communication ends up being a column-oriented protocol frequently. For example, Snowflake, you know, and Dremio's ODBC driver is using Arrow Flight SQL because that's the native thing that Dremio provides, and then converts it because ODBC is row-oriented. And so ADBC allows you to benefit from all that column-oriented interaction with your databases and keep the data in that column-oriented fashion and not have to do the conversions. And then we can even extend further because Arrow has its IPC protocol format, which is, you know, slight, flat buffer, small message, followed by, you know, the raw buffer bytes that are, no serialized, deserialized. You just take the raw bytes, stop them in memory and out. And so even a REST API could just return a stream of Arrow data right over HTTP. And that's going to be more efficient than most of these row-oriented client-server protocols, than most of these protocols that are using JSON. If you're trying to send large amounts of data, don't use JSON. And you can look at things like Trino, look at Apache Druid, column-oriented data analytic systems that only return JSON. And so in 2025, it's much clearer that, you know, Arrow is what you want for this fast query result transfer. And so earlier this year, me and my co-founders for Columnar punctuated this fact by doing by releasing this blog post. If you're curious for a more in-depth discussion of what I'm talking about, highly encourage read that. It's right on the Apache Arrow blog itself, so check it out. But the big thing to think about is also that in 2017, your average global broadband speed was about 39 megabits. And the conclusions that Hannes and Mark came to in their paper have only been strengthened by the fact that in 2023, based on, you know, these lovely sources from Cisco, your average global broadband was 110 megabits. And remember, their conclusion was that an arbitrarily fast network speeds, you should be using a column-oriented and compression-optional protocol for transferring your data, because the heavyweight compression and the row orientation and the serialization overhead is just not worth it. It's just slowing you down because the bandwidth isn't the bottleneck. The network transfer isn't your bottleneck. Your bottleneck is the CPU cycles to convert and serialize, compress, deserialize, decompress. And so that's what's happened. So this turns out to be a real strength in Arrow, and you can see that regardless of what your environment and programming language is, many, many systems have adopted Arrow for all of these reasons. Okay, whether you're looking at Dremio itself, ClickHouse, BigQuery, Snowflake, Databricks, Apache Data Fusion is a query engine built entirely on Apache Arrow. It actually started as a sub-project of Apache Arrow and then became a full top-level project with its own community. You know, DuckDB and so on. You know, it just proves it. Now, the question is, why are there so many systems that haven't adopted it yet? Like, what's the cause here? Is it Stockholm Syndrome? Is it afraid? Is it just fear of change? So my proposal to you guys is that it's not either of those. The thing that's holding it all up is the cost of switching. The actual cost to do the switch, to leverage Arrow and other things, is what's holding up all of those other systems. Because there's a steep learning curve. If you're, to go up this curve to actually switch to Arrow is a very steep learning. You either have to, if you're writing new code, you have to reskill and learn this entirely new thing and figure out how to use it in what you're doing. If you're adding to an existing application, it's easier to just trudge through your swamp than it is to actually migrate all of that code to a new API. And so a real goal that needs to happen for the Arrow community is we need to reduce that switch cost. Now, to kind of get the point across a little bit better, does anyone recognize the layout? The keyboard layout. Does anyone recognize it? Dvorak, yeah. This is Dvorak. You're probably all more familiar with the QWERTY format, layout, or AZERTY in France. And then bonus points if anyone can recognize this one. This is a layout called columnar. Now, with all of these, now here's the fun part about it. According to, well, show of hands, who uses QWERTY? Show of hands, who uses Dvorak or columnar? Yeah, that's what I thought. By all studies and all empirical evidence, the Dvorak and columnar layouts are faster and more efficient keyboard layouts for typing. The problem is, it is super hard to rewire your brain after decades of typing to use the other format, the other layout. Think about that for a moment there, is that this other thing is faster and more efficient, but you're not using it because, well, it's fucking hard to switch, and what you have now is fast enough. And that's what's keeping everything back on the Arrow adoptions. For their use cases, what they have is fast enough, or just, not enough people are complaining about the slowness. But the cost of switching is higher than whatever the cost is for them to not, to keep what they have and not switch. And the other thing about is you talk about this thing about the experts here who talk about this stuff all the time, like me, and talking about, oh, you should do this, you should do this. There is one drawback to being an expert, one of my favorite XKCD comics. Us experts are always going to overestimate the knowledge of the average person. Okay, we know that Arrow is the faster and more efficient route. We know that columnar data and that optional compression and all these things. And we assume that it's obvious. We assume that if we just say columnar, column-oriented, that people understand that. And if you're in data and you're in data engineering and you're in these niche areas, yes, it's obvious. But to your average data scientist, to your average engineer, to your average data analyst, it's not. It just isn't. We're assuming it is because, well, we are all the experts we're all experts, or at least significantly above average, in our knowledge and understanding of all this. And so, going back to what I was talking about with ODBC and JDBC, I have this lovely, lovely diagram that I have, which I'm very happy with. You know, despite the typos, because it's AI generated. And just try as I might, I tried so fucking hard to get them to fix these typos. And the AI gave up. It literally was like, I'm sorry, despite all of your attempts of clearly telling me what to do, I just can't seem to figure it out. But it gets the point across. We have our ODBC, JDBC from 1992. And then 2.0 and 3.0 versions. And we're still using it. And then that's the bottleneck. And everybody complains, why is my data connection so slow? Why is my database so slow? And then we add layers and layers of caching, and we add layers and layers of redirects and so on. Or we go to custom massive SDKs and lose all of the abstraction benefits. And all of this is happening because we just didn't change that middle layer. And so the point is to go from this to this. How do we make it easier? How do we make the switching cost easier? How do we reduce that switch cost, get the information out, teach more people about it, and encourage more of that adoption? And that brings me to my company. So I mentioned ADBC earlier. ADBC is, as I said, an API similar in concept to ODBC or JDBC. Single client API, swappable drivers, and your client talks just to the API. It's Arrow native, and it is column oriented the whole way through, as opposed to ODBC and JDBC, which are row oriented. But who here knows the pain of how do I find the ODBC driver for the thing I want? Yeah. You find some sketchy site, you download the thing, you hope it's the right package, and you're downloading this weird shared dynamic library that you're hoping won't hose your system, and then have to come up with this esoteric INI file. It sucks. And it's still that bad. And so the first thing that we did, so columnar, we are all Arrow community members, we're all Arrow PMC members. We're heavy deep in the Arrow ecosystem. I wrote the book on Arrow. My co-founder, David, was the one who first created ADBC, and so on. And so the first thing we did was we put out this open source utility that we called DBC. It is essentially a package manager for ADBC drivers. Think about like if you're familiar with Python UV, think about like UV for drivers. You can get it from, you can download it straight from GitHub, you can pip install it, you can UV install it, you can there's a curl script you can install it from. If you go to the documentation site, it is all there. It is installable by Winget, by Homebrew, like a lot of channels to get it. Now the point here is that you can get it, DBC install driver. Done. Now the driver is installed locally in a place that DBC knows about, that the driver manager knows about, that they can find it. Super simple. And now I can just import the driver manager. Notice it's using the standard Python DB API. Reduce the switching costs. You know, if your current code is using dbapi.connect, dbapi.connect. Super easy. Now, we did DBC install DuckDB, DB API connect driver equals DuckDB. And now I can execute. And then what we did was we extended the API, the DB API. We added fetch arrow table, fetch polars, fetch df, fetch dataframe. The point there is that, yes, if you just do fetch many, fetch one, the normal Python DB APIs, you're going to get Python data. But that means that your transposing it from the column-oriented Arrow data into Python tuples. The benefit is when you get to leave it as Arrow. You can go fetch record batch and get a record batch reader and stream the data. Polars and pandas are Arrow under the hood. So there's no conversion, there's no transposes, there's no conversion cost. You're wrapping it with a different library wrapper. It's that simple. Now, the best part there is that DBC is not tied to any individual programming language. It's just installing the driver. And then you have the ADBC driver manager has bindings and builds for C++, Ruby, Java, Python, Go, R, MATLAB, whatever language you want. You can use anything that can call a C function, can use ADBC, and we have a lot of bindings and wrappers to help that. And so alongside the DBC utility, we also released a CDN and a driver registry. And at least currently, there's 10 drivers. And we started what we call the Driver Foundry, which is an organization on GitHub. That is basically, we're working with the vendors to build these open source drivers using ADBC to improve the performance and working to keep the actual APIs and the usage in that familiar way that people are used to, or at least as close as we can, to reduce that switching cost. And that, I forgot to do that. Shh. That didn't happen. Anyways, so that's the gist. That's the talk. That's the point there.